Hi everyone, welcome to the channel. My name is Jack, and in this video, we're going to learn Python by building a mini project that we can use to encrypt and decrypt messages using the Caesar Cipher algorithm. The Caesar Cipher is named after the Roman Emperor Julius Caesar, who encrypted his handwritten messages by shifting each of the letters by some amount, so that if the messages were ever intercepted by his enemies, they wouldn't be able to read them. To decipher the message, you can shift the letters back by the same amount to get the original message. Now, by today's standard, this is actually a very weak encryption algorithm because it can be cracked really easily. However, it's still a great first introductory step into the world of cryptography and cybersecurity, which are really important subjects in the tech world. The project itself is quite simple, but we'll get to apply a lot of different techniques. So it's perfect for beginners who want to learn Python. Now, I'm going to assume that you at least have Python installed and already know some of the basics, but you're somebody who prefers to learn by getting hands-on with a real project. If you like the sound of that, then let's get started. Today we're building a Caesar Cipher. This is an encryption algorithm that works by shifting all the letters in a message by some fixed number. For example, consider the letters A, B, C, D, E. If we shift them by 1, then A would become B, and B would become C, and so on. Eventually, Z loops around to become A. So by applying this cipher with a shift of 1, the word cab becomes DBC. And we can apply this to any message to encrypt it. In cryptography terms, the original unencrypted message is called plain text. The encrypted message is called the ciphertext. In this example, we use a shift of 1 to encrypt the message. If we change the shift, for example, to the number 12, then the ciphertext also changes. And if we want to decipher the message back to normal, we'll need to know this shift number, so we can just move it back the other way. You can think of this number as the key. So how do we go about implementing this in Python? Well, it turns out that computers actually have a special number for each letter of the alphabet. And luckily for us, they are in order. For example, the letter A is number 65 and B is 66. This is a universally accepted standard, and it's called ASCII codes. You can look it up on Wikipedia. The plan here is to use Python to convert each letter in our message to this ASCII code number. And then we'll shift it by just adding the shift number, and we'll convert that result number back into a letter. So if we do that to all the letters in our message, then we'll end up with an encrypted message. Anyway, that's the plan. Now let's get started with the code. Let's open up our editor and create a new file. I'm going to call this file caesarcipher.py. And I'm going to start by creating the message that I want to encrypt. I also want to define the shift key that I want to encrypt the message with. So these two lines create two variables. One is called message and one is called shift. And variables are things like, you can think of them as placeholders for values that I can store some information in and refer to them and use them later. And the two types of values I'm storing here, well, the first one is a string. A string is like a sequence of characters. Things like words, sentences, or even single letters would be a string. The second type is a number. In this case, it's an integer. So Python makes a distinction between round numbers, which we call integers, and floating point numbers, which are like decimal numbers. Now that I have the data I want to work with, let's figure out how to go through each of these letters one by one and then actually shift it by this index. Just so that we don't get lost, I find it really helpful to write comments along the way. So to write a comment in Python, you just type the hash symbol here, and then whatever you write on that line will be grayed out, and you can read it as a developer, but it doesn't have any effect on your code. So here I want to go through each of the letters in the message, and I'm writing this again for my own clarity, so when I read it, I know what my program is doing. To go through each character in the message, we're going to loop through it. And this is how we write a loop in Python. So if you have a variable that can be iterated upon, iterate means you can go through some element of them one by one. In this case, we can iterate upon the string because each element is one of these characters. So if we do this for x in message, each time we iterate, x is going to be equal to one of these characters, one by one until it reaches the end of the string. And then in the scope of this statement, which is one indentation level in, we can do something with x. And something we can do really basic is just to print it. So the print function is a built-in function in Python, and that would just make this variable show up in the terminal. Let's actually run this now and see what happens. I've opened up my integrated terminal, which is on a Windows that's control backtick or on a Mac that's command backtick. And you can run your Python program by typing Python and then space and then the name of your file that you created. So in this case, caesarcipher.py. And if we run it, we see that each print statement is on a separate line. So we're actually going through each of these and printing one character at a time. So that's pretty good. And I'm going to constantly run this at each step in the development just so you see how the application changes as we work on it. So I'm just going to clear my terminal and then we can move on. The first thing I want to do is convert this character to the ASCII code. And Python actually has an inbuilt function to help us do this. The function is spelled ORD, which I think stands for ordinal, and it returns the Unicode for that one character string. So luckily in this case, X is going to be a one character string. By the way, we don't have to name this X, we can call it anything else we want. And typically, I like to use short variable names for things that are obvious, but it's also really good to use descriptive variable names that help us understand what X actually is. So in this case, I'm just gonna change that to char so that we know that this is a single character in this loop. And I'm gonna create another variable to store this output, which I'm gonna call char code. So instead of printing just char on its own, I can print char and then I'll put a comma here and also print the char code. Let's run that again. Now in our print statement, next to the letter, we also get the ASCII number or the Unicode number for each character. And now that we have this char code, we can just add this number, this shift offset to that char code, and we'll get a new char code, which is the Caesar Cipher encrypted char code. So let's do that. So new char code equals char code plus shift. And these are both integers, so we can actually do arithmetic on them. Let's print that out as well. And so in our printed terminal, you can now see the three characters, the letter, the original char code, and the Caesar Cipher shifted char code. We now have to convert the new char code back into a string because it's a number right now. Again, Python has a helper function to let us do this, and this time the function is chr. And then we'll just put in our new char code in there and we'll get the string. Again, we'll need a new variable to store this, so let's call it new char equals char new char code. Log that out as well. And now when we run it again, we actually see the whole transformation of this letter. So the letter E, for example, the char code is 101. We shift it by 7, so it becomes 108. And when we map that back to an alphabet, it becomes the letter L. Now, to finally get the full result of our encryption, we need to add all of these characters back together to form the encrypted message. To do that, we can just create an empty string first. And I'm going to call it result. And it's just going to be double quotes and nothing in between because it's an empty string. And each time I loop through this, I'm going to append this new char to the empty string. So the result string is going to become whatever the result was before plus the new character. And now I'm just going to remove this print line and instead only print the result at each iteration. So this time, every time we go through a character in the message, we should see the result getting built up slowly. So you can see here it starts adding O and then OL and then the rest of the characters, and we finally have the encrypted string as our output. And I don't need this to be within this loop anymore, so I'm just going to take it out of the scope of the loop. If I backspace it, it's no longer indented on the level of the loop. So when I run it again, it's not going to print each time, it's only going to print once. Okay, so I think the Caesar Cipher is working at a very basic level, but you could see that there's still some bugs. For example, we get some really weird characters here, a couple of weird characters and this parentheses. So that's because we actually also try to encrypt Unicode characters that are not letters, like this comma, this space, and this exclamation mark. So the first thing we want to do to fix that is to make this loop ignore any character that isn't a part of the alphabet. If it's not part of the alphabet, we just want to add that to the result as it is. So how do we do that? It turns out that Python also has a helper function that we can call on a string to check whether or not it's part of the alphabet. So if we just do char and then is alpha, this statement will return a Boolean. A Boolean is a value that is either true or false that will tell us whether this is part of the alphabet. So we can check if the character is part of the alphabet. This is something called a condition statement. And if it is, we'll do all of this stuff. So I'm going to indent that to make all of this code only execute in the scope of this condition, only if this becomes true. So let's clean that up a little bit. And let's run that again and see what happens. So now it works. You can see that it completely skips any character that isn't an alphabet, but now the ciphertext result is shorter than the original string because we actually dropped the characters instead of just preserving them. What if we wanted to preserve them? So here the problem is that if the character that I'm looking through is not part of the alphabet, I don't do anything to it. This condition is going to be false, and I just skip this part of the code and go through the next character. That is why our exclamation mark and our space bar is dropped from the encrypted message. And if that's not what we want, we can add an else condition to the statement and have it do something else. So we can do it like this. And if the character is not part of the alphabet, we can just add that character directly to the result without having to do all this stuff here. So in this case, I'm adding the original character, not the new character. There is no new character here. And let's run that and see what happens. So now the encrypted message actually preserves the non-alphabetical characters like the comma, the space bar, and the exclamation mark. By the way, we can actually make this line look a little bit nicer. We don't have to write result equals result plus new char. There is a shortcut for this and we can write it like this instead. So result plus equals new char, and it means the same thing. It's just a little easier and cleaner to look at. And Python has many shortcuts like this, and this is what we call in Python syntactic sugar. It's just kind of shortcuts and little abbreviations that make things hopefully easier to write and read. Okay, so running it again, I have yet another problem, which is one of my characters is still translating weirdly to this caret sign. And that's because this character is actually the W character. But when I shift it by 7, it goes past the letter Z and it sort of lands in these weird symbol characters here. W is character number 87 and Z is number 90. So when it goes plus 7, it actually goes all the way to 94, which is the caret symbol. That's not what we want though. We want it so that when it reaches Z, it kind of loops back around, goes through A, and starts counting from there. And that's the proper Caesar Cipher behavior that we want. So how do we go about doing that? Let's just take a really simple approach first. So let's say that we get an offset, a new char code that is greater than 90. Well, in this case, we know that it's gone beyond Z, and we have to sort of loop it back over to A. So we could do that by just subtracting 26, which is the range of the alphabet here, and that kind of brings it back, lets it loop around. Let's just try that really quickly and see if it works. So here, if the new char code is greater than 90, which is the char code of the letter Z, we're going to subtract 26, and hopefully that will make it loop around. Okay, and running this again, I see that my W is fixed, but funky things start happening to some of my other characters. Well, the reason is it turns out that all the lowercase characters have a different char code than the uppercase ones, and all of the lowercase ones are actually greater than 90. So this 26 shift is actually applying to all of the lowercase letters, whether or not it's beyond the actual lowercase z. Instead of trying to solve that problem directly, we can actually work around it. Because if the lowercase characters are causing us trouble, we can just convert the whole message to uppercase first and then perform the Caesar cipher. That's probably the simpler solution, so we don't have to solve the same problem twice. So let's go ahead with that first. And to do that, we'd use another Python input function called upper, and this will, if you can see here, this will return a copy of the string converted to the uppercase. So now instead of looping through the original message, we're looping through the uppercase version only. And now when I run this, the Caesar cipher looks correct. At this point, our application works, but we can still do things to make it a little bit nicer. For instance, these things that we're using here, they're called magic numbers. They're basically numbers that we use as part of the code without any kind of logical explanation about why they're there. So to fix that, it's usually better to define these as a variable as well. We can call it a constant variable, so it's something that we don't ever change, but it's easier to read. So this number 90, it's actually, what it means is it's the last character index. It's the ASCII character code of the letter Z. So let's actually give that a descriptive name. So now I'm calling this last char code, and this is a variable as well, but by Python convention, when I write it with all caps, it usually indicates to the reader that this is a constant variable and I'm not expecting it to change, and it's better than using this number magically inside the actual code itself. So let's go replace this. And then we'll do the same for the 26 here. And if I run it, the program should still work the same, except that this logic is just a little bit more readable and more maintainable. Now, what if I wanted to reuse this code, maybe as part of another application, or maybe I just want to encrypt a lot of different messages at once? Or even if I want to reverse the shift and use it to decrypt messages. To do that, I'll need to organize this code into a logical unit that I can reuse and that it has an interface that's easy to understand. So in Python, we're going to do that by putting this code into a function. And a function in Python is basically a block of code that we give it a name, and then anytime we call that function, we can invoke this entire piece of code with different parameters, different inputs, and get the result out of that. So that sounds exactly like what I need to do here. To create a Python function, we write def, which stands for define, and then we write the name of the function. In this case, I'm going to name the function Caesar shift. And this is how you create a function in Python. This function does nothing because there's no actual logic in there yet. And we also need to have these parentheses to tell Python what arguments it can accept. So the arguments are like input to a function. Now, in this case, the arguments we have are the message and the shift. So those are going to be the arguments for our function. Those are the only things we care about that could possibly change every time that we run this, but everything else, the structure, even these constants, we want it to stay the same. That's why only these things are going to be the arguments. With that, I can actually just move this entire block of code into the function. And again, to make it within the scope of this function, I have to indent it. Okay, so now I have this function. What happens if I run my program? Well, actually, there's nothing being output or printed out. That's because even though I've created the function, I actually haven't used it yet. So let's go ahead and use it. To use a function, we just write the name of the function and open these brackets up. And if I run it like this, it's going to fail because I'm not passing it any arguments when it's expecting 2 arguments. And I've actually defined my arguments here, message and shift. Because I have this function, there's no need for me to even store these as variables anymore. I could just delete these entirely and then write it in here instead. And if I run the Python script again, it should work. See, now I'm back at my same result, except that now I have this nice function and I can reuse it to call the same piece of code with different inputs. So for example, I'll do something like A, B, C, D, E. And then maybe I'll change the shift to that. Okay. So here I've called it different ways. And I can even use it to decode a Caesar cipher. So for example, let's copy this ciphertext over here. And let's call Caesar shift again, except this time we'll pass in the ciphertext. And this time we'll pass in the negative value of the key. So we're shifting it back to the plain text form. See if that works. And this actually fails. I mean, you can see that some of the letters are shifted properly, but again, we have some problems with the characters that are at the boundary of the alphabet. That's because our condition here only checks if it's bigger than Z. It doesn't check if it's less than the first char code, which is A. So we can add that condition as well and see if we can fix that bug. And we have to also define first char code, which if you look in the ASCII table, the char code for A is 65. And now when I run this again, you can see that the decryption works properly because now I'm clamping the shift both ways. By the way, just as a nice thing, so that we don't actually have to look up the first and the last char code and have these magic numbers again appear in a constants like this, we just actually could call the ORD function with A here and then call it with Z there. This way we don't even have to look up the table because we know that this is going to give us the value we want. And the same with range, we don't even have to hard code this anymore. We could do it with the arithmetic here. Except that with this, we actually have to add 1 to it because when we do this, the index start counts as 0. So it counts the first entry as 0 instead of 1. So it will end up being 25 if we just do this on its own. To get it to 26, we do have to add 1. But now let's just save that and run it. And yes, everything still works, except that everything is also more logical and more readable, which is actually a really important part of development as well, especially if you want to work in a team. Now for the last part of this project, I want to turn this into an interactive application so that when I run it, I want to prompt the user to type in a message, and then I want to run Caesar shift on that message. How do we do that? So first, let's get rid of all of this stuff. We don't need it anymore. We'll have our Caesar shift function here. I'm just going to collapse that so it's easier to read. To capture user input in Python 3, we use an inbuilt function called input. Whatever we put in here is going to be the prompt that the user sees. So I'm just going to write message to encrypt. And I'll put a colon there. And if I run this again, I'm going to see that it prompts me with this message to encrypt, and I can type, whatever I want, and I enter that. Nothing happens because we're not doing anything with this input yet. So the first thing we have to do is actually store this message. And I'm going to call this user message here, just not to confuse it with this variable name. Again, I would recommend avoiding reusing variable names as possible. Even if it means the same thing, just add some kind of prefix to it. It's going to save you a lot of trouble debugging, because most of the bugs I see at the beginner level is when you reuse variable names and you're not aware of it, and it just makes your application do unexpected things. So now we have the user message. We'll run Caesar shift on that user message. And we'll just hard code the number 7 for now and see if that works first. Okay, so now I can type in a message and it will run a Caesar shift on it with the key of 7. But let's say that I want to also pass in the key here. So let's try that. Again, I'm going to call this user shift key just to make it clear that this is the value coming from the user. Okay, so let's run that again. And I get an error because it says supported operand types for plus, int, and string. It's really helpful to learn how to read error messages in Python. This one, it means that you can't plus together two different data types, ints and a string. If we open this, we see that we use the shift and then we try to add to the char code. The char code we know is an integer because that hasn't changed. But what has changed is this shift value that we're passing to it. Why has that changed? Because now we're passing user shift key as the input instead of the number 7. But something that I didn't tell you was that when you call input, whatever we get from the result of this is always going to be a string, even if it's a number like this. And this string 7 is different from the number 7, because a string 7 would be actually, it would be in the quotes, and you can't add that together with a real number like 12 or 13 or whatever. It just doesn't know how to do that. So we actually have to convert this string back into an int. It's really easy to in Python. You just type int and then you wrap that around, and that will convert whatever string this is. If it can convert it, if it's not something totally crazy, it can convert that to an int, and now this will be an int as well. So try that again and this should work. Okay, so that fixes the problem for us, and the application seems to work pretty nicely now. Congratulations, you've completed the project. If you have any feedback, or if there's anything you struggled with, or if there was anything was unclear, then please let me know in the comments below. It's my goal to make coding accessible and fun for everyone who wants to learn. So your feedback would also help a lot of other people. If you enjoyed this project and you want to try something a little bit more challenging, then I recommend you check out this video where I show you how to make a Wordle puzzle game in Python. Otherwise, thank you for watching. See you next time.